Did you know that astronauts age slower than people on Earth? In this video, we'll explore the fascinating concept of time dilation and how it affects aging, particularly in space. Astronauts get to do this amazing thing. They live and work in the International Space Station, conducting experiments and exploring the unknown. But did you know that time works a bit differently for them up in space compared to us down here on Earth? It's a mind-bending concept that challenges our everyday understanding of time. It's true. Astronauts actually age a tiny bit slower while they're orbiting our planet. This isn't science fiction, it's a real scientific phenomenon. To understand why it happens, we need to learn about Albert Einstein and his famous theory of relativity. His groundbreaking work changed the way we think about time and space. It's all about how time isn't the same everywhere in the universe. Depending on where you are and how fast you're moving, time can behave in strange ways. Time can actually be stretched and squished, like a rubber band. This means that astronauts traveling at high speeds and experiencing different gravitational forces live in a slightly different time frame. Einstein's theory of relativity tells us that time is relative. It's not a fixed constant, but can change based on various factors like how fast you're moving and how strong gravity is around you. Einstein's theory of relativity is like a rule book for the universe. It helps us understand how everything from the smallest particles to the largest galaxies behave. It has two main parts. The first part is called special relativity, and the second part is general relativity. Special relativity says that the speed of light is constant, meaning it always travels at the same speed no matter what. This is true even if you're moving towards or away from the light source. General relativity, on the other hand, says that time and space are connected. They form a four-dimensional fabric called space-time. Imagine space as a giant sheet and time is woven into it. This sheet can be bent and stretched by massive objects. Massive objects like planets and stars warp this sheet, affecting how time flows around them. The more massive the object, the more it warps space-time. This warping of space-time is what we feel as gravity. It's why objects fall to the ground and why planets orbit stars. Now, let's see what this means for our astronauts. When they travel at high speeds or are near massive objects, time behaves differently for them. Imagine you have two identical clocks, one on Earth and one on a spaceship traveling at a very high speed. The clock on the spaceship would tick slower. Scientists have confirmed this with precise instruments, proving Einstein's theory correct. The faster you travel, the more noticeable time dilation becomes. Think about it like this. Imagine you're on a train and you throw a ball forward. To you, the ball seems to travel at a normal speed. But to someone standing on the platform, the ball appears to be moving much faster because it's also moving with the speed of the train. Similarly, as an object, or a spaceship, approaches the speed of light, time slows down relative to a stationary observer. Scientists have even observed time dilation on a much smaller scale with atomic clocks flown on airplanes. Gravity also plays a role in time dilation. The stronger the gravitational pull, the slower time passes. Remember our warped space-time sheet? Imagine a heavy bowling ball placed in the center. The closer you get to the bowling ball, the steeper the curve of the sheet becomes, and the slower time moves. This means that time passes slightly slower at sea level on Earth than on top of Mount Everest, where the gravitational pull is slightly weaker. And in the extreme gravity of a black hole, time would essentially stop altogether. So, how does this all relate to astronauts on the International Space Station aging slower? Well, astronauts on the ISS are both traveling at high speed and experiencing slightly weaker gravity than on Earth. This unique combination of conditions has a fascinating impact on the passage of time. These two factors combine to create a small but measurable time dilation effect. Essentially, time moves a bit slower for them compared to us on Earth. Astronauts on the ISS age about 5/1000ths of a second slower every 6 months compared to people on Earth. This might seem insignificant, but it's a remarkable demonstration of the principles of physics in action. It's not enough to make a noticeable difference in their lifetime, yet it's a fascinating example of how Einstein's theory of relativity plays out in the real world. Now let's move it up a notch and imagine a future where humanity embarks on an interstellar journey to Proxima Centauri b, the closest exoplanet to our solar system, located about 4.24 light-years away. If we could build a starship capable of traveling at close to the speed of light, time dilation would become a crucial factor for those living on board. As the starship accelerates to near-light speeds, the time experienced by those on board would slow down relative to those of us remaining on Earth. For the astronauts, the journey might feel like it takes just a few years, even though decades could pass on Earth. This means that while the crew ages only a little, entire generations could pass on Earth by the time they reach their destination. This profound effect of time dilation would make communication with Earth a challenge, as the time gap would be ever increasing. However, it would also mean that the crew could potentially live long enough to see the fruits of their journey and exploration. While back on Earth, their mission would become a legend passed down through generations. The concept of time dilation in interstellar travel underscores the incredible and often counterintuitive nature of our universe. It brings into perspective the immense scale of space and time, and the extraordinary challenges and opportunities that lie ahead as we reach for the stars. Our journey to Proxima Centauri b would not just be a testament to human ingenuity and perseverance, but also a powerful reminder of the cosmic dance of time and space that governs our existence. So while astronauts on the ISS experience time dilation in small, almost imperceptible amounts, interstellar travelers would face a much more dramatic shift in their perception of time. It's a fascinating thought experiment that illustrates just how strange and wonderful the universe can be. Did this video help you wrap your head around time dilation? If so, drop us a comment and let us know. Please give us a thumbs up, and why not check out one of our other videos which are currently on your screen.